this is a banana, and this is my energy bill. This is all I've had since the past 10 hours to both write and produce my talk, whereas this is what your computer needs to merely process it. This is 439.32 kilojoules of energy, whereas when you do the math on it, it comes out to be 2,160,000 kilojoules of energy for a mere 8-hour computing time. That is an insane disparity. Why is that so? That's because your computers are not built like human brains. They are built with a von Neumann structure, which means they have a processor that processes the data and a memory that stores the data. These two communicate with each other and form a computer. Well, that doesn't seem great because we are now working on artificial intelligence and machine learning, where we are teaching computers to learn like human brains. Essentially, what we're doing is we are forcing our brain's functionality on a structure that doesn't look like our brain. We don't have a processor and a memory that transfers information between each other because that would be very inefficient. A lot of energy would be lost between the transfer. Well, that is exactly what happens because a study says that by the year 2040, we are going to need 10 to the power 27 joules of energy to even do the same amount of computing that we do today. Well, that's not good because that is literally bigger than the world's energy budget. We are clearly going somewhere wrong with the von Neumann structure, and we need to replace it with something that's a bit more brain-like, don't you think? Well, how does a brain work? It has a bunch of neurons with a synapse in between. There's a flow of charge in the form of ions or charged atoms, and there's an electric signal that is caused because of it. Flow of charge, electricity. Electricity is flow of charge, and that is exactly how your computers work. Is your brain a computer? Well, that is exactly the epiphany that Professor Mead had back in 1980s when he proposed the idea of a neuromorphic computer. A neuromorphic computer is nothing but a computer that looks exactly like a human brain. It has artificial neurons and SNNs, which are spiking neural networks. These neural networks are built exactly like your brain, as I said, which means they are solving both of our issues. They can now solve machine learning problems very efficiently, and they are also energy efficient because a neuron only fires up when there's an electric field between it, whereas your von Neumann structure is always consuming energy every time it is on. I think we've solved something. So next time you have a banana, remember, you and your computer might be consuming the same amount of calories very soon.